This is the editorial for Codeforces round 982 diff 2 question B Stalin sort. The question states that Stalin sort is a humorous sorting algorithm designed to eliminate elements which are out of place instead of bothering to sort them properly, lending itself to a big O and time complexity. So let's see how it is. We start from the second element in the array. If it is strictly smaller than the previous element, then we delete it. We have to ignore those which are deleted. Continue iterating through the array until it is sorted in non-decreasing, that is increasing order. For example, this array is given, so start from 1. Is 4 greater than 1? Yes, keep it. Greater than equal to 1? Yes, keep it. Is 2 greater than equal to 4? No, remove it. Is 3 greater than equal to 4? No, remove it. Is 6 greater than equal to 6? 4? Yes, it is, keep it. Is 5 greater than equal to 6? No, remove it. Is 5 greater than equal to 6? No, remove it. Is 7 greater than equal to 6? Keep it. Yes. Is 7 greater than equal to 7? Yes, keep it. So this is our array after applying Stalin sort. Now we define something. We define an array as vulnerable if you can sort it in decreasing order by repeatedly applying Stalin sort to any of its subarrays as many times as is needed. So given an array A of n integers, determine the minimum number of integers which must be removed from the array to make it vulnerable. So given an array, the array is vulnerable if after applying Stalin sort to its subarrays, what we can do is we can make it decreasing. So see this example. Um, so basically, suppose the array is 1, 4, 2, 3, and we apply Stalin sort here. What do we get? We get 1, 4. Nothing more can be done with this array. But if we remove 1 from this array, then we apply Stalin sort here. What we get is 4. Now since it is a unit array, it is decreasing. Similarly, let's look at the example given here, 3649252. So you can always notice that a solution exists because suppose let's think about this, and every array has a starting index, right? Every array starts somewhere. So like this array starts at 3, so we can pick a starting index from the array. Let's pick 6 as the starting index. Now we have to make the array decreasing, right? So if something exists here, can this be part of our array? No, right? It can be, but let's remove it. So suppose this was 9 and they are starting from 6 and removing 9, you would say, but if we included 9, this would have been a decreasing array, right? But the thing is, we must have started at 9 as well, right? And when we started at 9, we must have included this part. So when we start at 6, we don't care if the previous elements were greater than 6, smaller than 6, equal to 6, nothing. Because if this part, the remaining part, let's suppose this something was there as well, if this part could have been taken, we would have taken it from here only. We wouldn't have come at 6. If we are coming at 6, let's pick 6 as the starting index and remove the elements before it. Even if they could have formed a decreasing array, let's think that uh, anything before 6 does not exist in the array, right? So now you must have understood why, because if it was decreasing before 6, we would have included that part before coming to 6 as starting index. So now let's pick 3 as starting index, right? So if 3 is starting index, every element after 3 must be smaller than 3. So we can't have things like 6, 4, 9, 5. We can't have them. Now You must be saying, what if we apply Stalin sort here? If we apply Stalin sort here, 3, 6, 4, 9. If we apply Stalin sort here, we get 3, 6, 9. No further Stalin sort can help us remove anything from the array. And this array, as a result, is not a decreasing array. So we have to remove some things, right? So think about it. If we are starting from 3, no matter how many times we apply Stalin sort, we can't remove things which are greater than 3, right? So suppose 9, no matter how many times we apply Stalin sort, the greatest element, if it is 9, we can't remove it. It is impossible to remove. So suppose it was 3, 4, 5, 9, 2. No matter what sub array we pick this sub array, we pick this sub array, we can't remove 9. Removing 9 is impossible. So what can we do? We can remove 9, but then 5 is the maximum element and we can't remove 5, can we? Using, so let's cut 9 first of all. Using Stalin sort here, since 9 is cut, this array will be converted to 5, 2. But 5 can't be removed. 5 is greater than 3, so 5 has to be removed. So again, we are cutting 5 as well. Now Stalin sort here would give us 4, 2, right? Sorry, I made a mistake. Stalin sort here would give us 5. So this makes the array 3, 4, 5. And this is an increasing array, so Stalin sort can't be applied. So if you are removing an element greater than 3, where we have to remove this as well. So the array is now this 3, 4, 2. If we apply Stalin sort here, we get 3, 4. Again, this is increasing, so we have to remove 4 as well. And afterwards, every element after 3, we are doing this till every element after 3 is smaller than 3 or equal to 3. So no matter what there is, 2 again, 1 again, 2 again, 1 again, 2 again. If we apply Stalin sort from the starting index to the ending index, everything that is smaller than 3 would be removed. So if you look at this part, this is increasing, right, not decreasing. But if we apply Stalin sort at 3, since we have removed all the elements greater than 3 from the array, the remaining elements are smaller than 3 or equal to 3. So we apply, if we apply Stalin sort, everything less than 3 would be removed. So the array would be comprising of 3 threes, or only 1 3. It will contain nothing else. So what do we get from this? We get from this is, if we are choosing this as the starting index, we are removing everything that is greater than 3 from our array. So look at one thing, the maximum size of the array can be 2000, so n square algorithm can be used. So suppose 3 is the starting index, so we have to remove 6, we have to remove 4, we have to remove 9 and 5 as well. So the remaining array is 3, 2, 2. So how many elements did we have to remove? 4, right? 4. Suppose 6 is the starting index, let's remove 3. 6 is the starting index, so we have already removed 1, 3, and greater than 6 is 9. So we had to remove 2 elements for 6. Um, let's keep 4 as the starting index, so we had removed 2 elements, 3 and 6. Now we have to remove 9, we have to remove 5, so total 4 elements are removed. um, let's keep 9 as the starting index. If 9 is kept as the starting index, we are removing 3 elements, 3, 6 and 4, and afterwards there is nothing greater than 9 is there. 2, 5, 2, all are smaller than 9, so we are removing a total 3 elements. If we keep 2 as the starting element, we have to remove 4 elements, 3, 6, 4 and 9, and afterwards we have to remove 1 element, 5. So 2, and if we keep doing this, we'd find that 2 is the minimum number of elements that we can remove and make the array vulnerable. Where does it occur? It occurs at 6. So if we choose the starting index at 6, we remove the first element and we remove 9. What happens is the array becomes 6, 4, 2, 5, 2. Now of course this is increasing, but we have a tool Stalin sort, so we apply Stalin sort to this whole array, and everything after 6 gets removed, so the array becomes this, which is decreasing. So what we understood is, if we pick one element as the starting array, so if we pick suppose the fourth element as the starting array, we are removing 3 elements, because if the fourth element is the starting, the first, second and third element have been removed. And no matter how many times we apply Stalin sort, we can't remove things which are bigger than this. So if we have pick 3 as starting, um, yeah, no matter how many times we apply Stalin sort, we can't remove the biggest element 9. And if we eliminate 9 there, we can't eliminate the biggest element 6. We can't eliminate the biggest element 5. We can't eliminate the biggest element 4. We can't eliminate this, so we have to remove them from the array one by one. Now afterwards, suppose you are picking 7, and from this array the maximum element is um, smaller than equal to 7. The maximum element is smaller than equal to 7. Now we don't need to worry, because we can apply Stalin sort to the whole array, and everything after 7 that is smaller than 7 will be removed. So this is our idea. Now how do we apply this? We apply it like this. So we pick a starting index. So suppose 3 is our starting index. We see how many elements were before 3. So suppose 2 elements were before 3. We add them to a variable, and we check how many elements are bigger than 3, strictly bigger. So 3 is not counted, we have to count from 4 onwards. 6 is strictly bigger, 4 is strictly bigger, 9 is strictly bigger, and 5 is strictly bigger. So 4 plus 2, so 6 elements we have removed. This will be our algorithm, and for every index, from every index we have to see what is the minimum number of elements after removal of which the array becomes vulnerable. So the code for this looks something like this. We take how many elements are there in the array as input. We make a vector of size n. We use a for loop. This is nothing but a for loop, and we take input for the vectors elements. We set a variable res. um, Now why am I keeping this as int max is, suppose there is something like 5 million, then if I'm taking minimum of int max and 5 million, of course I'll get 5 million. So I'm keeping the maximum integer limit possible, so that if I am taking minimum, what I get from my result would come as minimum. So suppose for the first element here, res is int max, so of course any answer that I get will be smaller than int max, right? So this will be set as res. So we are applying a for loop for every element of the array. We are setting a variable lrem. Rem means how many elements do I have to remove. Now first I'm adding the index to the variable. Why? Because as I said, I here means I'm choosing, suppose, the zeroth index, the first index, the second index as the starting element. If that is the starting element, any element before that has to be removed, right? So remove plus equal to I, and I am applying a for loop from I to n. You can of course apply I plus 1 to n. So what I'm checking here is how many elements greater than my current element are there after it. So from I plus 1 to n, how many elements are there after it? So um, think of it something like this: if v of j is greater than v of I, then I do rem plus plus, right? If v of j is greater than v of I do rem plus plus. And after all of it has been done, I set again, I set res to the minimum of the res before and removal now. So this ensures that we get from the whole array the minimum of all elements that has to be removed, and then we give out the answer. So for first index, it takes up how many elements are before it, then it checks how many elements after it are bigger than it, and then at last we just minimize the res, and at last we output it. That is the code for the question. Thank you.